let's begin a bit of a discussion on this, okay? At the moment, what we're doing is we're exploring. We're just kind of fanning out and seeing what happens, okay? Now, one of the first questions we raised was, these two here, do these constitute different ages? Well, I'm going to pose the question to you. Do they or don't they? And how do you know whether they do or don't? Does anyone want to suggest an answer? What do you reckon?
I don't think they do because we're just adding and multiplying and the order doesn't really matter.
Aha. So this idea we learned all the way back in year 7, which is that addition and multiplication are, does anyone remember the name of it? It starts with a C, where you can change order and do whatever you like. It's not a common word, which is ironic because of what the word is. We say operations are commutative if you can do them in any order and you can change things around and you don't change the answer, okay? At the moment, we've been thinking about addition, and then we're going to think shortly about multiplication, neither of which affect the order, okay? And ultimately, the final question is, like, what is the final question?
The oldest one.
Say it again.
The oldest one goes back then. So.
Wait, no, the question, not information. What's the question that's being asked? What are their ages, right? To which I would reply, I think these two give us the same information, okay? So I'm just going to take off this one, like so. Okay. Now, I've also put you at a slight disadvantage, which I can't ask you to come up randomly, and then you sort of wrote, and some of you were like, oh, mine are there or mine are not there, so I can't put them down or whatever. These are in somewhat random order, okay? I wonder if anyone has an order to the way that they've written theirs down, because that will help us to make sure we get all of them. Fawa, what did you put as your order? How did you lay it out?
I started with the age of 1, like 1, 2, 10,
yep.
Then 1, 3, 9, then 1, 4, 8, then 1, 5, 7, and 1, 4, 6.
Okay, so if you lock in the age of one child, then it becomes quite easy to work out, well, the other two have to be a certain limited number of ages, right? Why are we doing this? You want to explore in a logical fashion, like if you have a space to explore, if you explore it in a logical fashion with a pattern to it, then you'll make sure that you don't miss anything, right? Whereas if you go about it in somewhat random order, it's like, oh, did I get to that spot? I don't know, and it's hard to keep track, okay? So again, this is a way that you explore. I'm going to pause for a moment. I've written down, or you've written down rather, the ages of the 3 children as possibilities. But all I've really thought about is the first piece of information. Okay? Now I'm going to think about the second, which requires me to do what? I'm going to have to multiply across, right? Now, just a little minor note, which is not important here, but I'm going to do it anyway. In English, we only have 26 letters. So we kind of run out really quickly of letters when we're trying to describe things. So that's why we use Greek letters so often, and also because Greeks did so much mathematics. Some of you will see this symbol. Does anyone know what Greek letter that is? It's sigma, right? So because it's the Greek equivalent of the letter S for us, you will often see that when you want to describe the sum of a set of numbers, okay? So when you see sigma, you should read that as sum. All of these have the same sigma, they're all 13, okay? I want a product. So therefore, instead of this, which everyone knows and recognizes as a mathematical symbol, I'm actually going to use, it doesn't look really different, but hopefully when you see them together, it's distinguished enough. I'm going to use a capital pi, because Greek letters have capitals and lowercase just like we do. If sigma stands for sum, what do you think pi stands for? Take a blind guess. Have a look at the clues. It stands for product, okay? So I'm going to work out all of the products over here. Can you help me out? What's the first one? 20. This is 36. Yeah, I can. That's why I'm in maths enrichment. Okay. 35. What's this?
27.
32. What about this one?
32.
This we already have though, don't we? Right? Because we already decided these are sets, so the order doesn't matter. So I'm going to just pull this one off, which is fine. It's fine. It's okay. We're exploring. It's all good. But we're actually at the same time, you might notice, we're eliminating options. Okay, what do we got here?
11. 48. Wait, is that wrong?
Okay. What's this one? 2 times 5 times 6, that's 60. And 2 times 4 times 7, 56. Okay. Okay, now I'm going to ask you to go back because I know for a fact, and you can know for a fact as well, that we haven't got them all. How do we know we haven't got them all? Any suggestions? Yeah, what do you think?
Because we haven't tried out every single possibility for every single number.
Okay, number one, it's like, well, we just haven't done them all. Like, look, this is a pretty short list, okay? But actually, even the question tells you something a bit quicker than that. There's something in the question that tells us I don't have the full list yet. Do you remember? They both worked out that the three ages multiply, and they pointed to the door, and they were like, oh, it's that number, right? Now, when they both looked at that number, they both looked, and what was the person who, whatever the other person was, what was their response when they both looked at the number?
I need to know more.
I need to know more. I need to know more. Now have a look at the information that you've got here. If this was the complete set, then I don't need to know anymore. If we're both looking at the door and we can see 20 on the door, or we can see 32 on the door. Do you see why in this situation I don't need any more information? Why?
Because you already got the variables, the information you need.
They're all different.
Okay, now the reason why I have all the information I need is because every single one of these numbers is unique, right? So if I saw 32, then I know this is the age, like up on the door, right? If I saw 48, then I know this is the age, right? Because they're all different. But the fact that he suggests, or she, whoever it is, says, I don't know yet, I need to know more, means there must be more ages, some that repeat what's here, okay? So I'm gonna ask you to go back. We're clearly not finished exploring yet, okay? Can you think, this is, what have we got here? 9 possibilities. There's a few more, not lots more, I should point out. In fact, you've got more than half of them, but there are some missing. Can you try to work them out?